We'll prepare our dataset using Excel. Before moving into analysis, we'll start by loading the dataset and organize it properly so it's ready for reporting and visualization. First, load the dataset called raw data. This sheet contains original data that we'll use for our project. Next, duplicate the raw data sheet. We always keep the raw data untouched just in case we need to refer back to it later. Rename this new sheet as a Superstore sales. This will be our working sheet where we clean and analyze the data. Now select the entire data set. Go to the Insert menu and choose Table. This converts the data into Excel table, which makes filtering, sorting, and analysis much easier. Once the table is created, quickly check the data set. Make sure all columns are included and the headers look correct. At this point, our sales dataset is properly structured and ready to use. Next, let's create a new sheet to document the purpose of this project. This helps anyone reviewing the file understand the business context and objectives. Name this as a project notes. Under the business context, we'll enter the following things. Like this project stimulates sales data received from multiple distributors across global markets to support the commercial decision making and reporting. This gives a clear explanation of what the data represents. Now let's list the key business questions this analysis aims to answer. How do sales and profit differ across markets, countries, and regions? Which product categories and subcategories makes the most or least profit? How do discount affects profit margins and zero profit sales? Which categories or regions perform better or worse than average? These questions guide our analysis. They help us identify the key drivers of sales, profitability, and the impact of discounts across different products and regions. With the data prepared and the project goals clearly defined, we are now ready to move forward with analysis and visualization. In this section, we'll perform data consistency checks to assess the quality of our data set. Before starting any analysis, it is critical to understand whether our data contains missing values or unusual entries that could impact the results. First, create a new worksheet. Rename this sheet as Data Quality Checks. This sheet will be used to document all our data quality findings. Now we'll run a few basic checks to identify missing or inconsistent data in key columns. We'll check for missing sales values, missing order dates, negative profit values, missing quantity values. To check for null sales values, enter the following formula, that is equal to count blank of. So this counts how many records have missing sales values. The result shows that null sales values are 0. That means every record in the dataset has a sales value. Next, let's check for null order dates. Use the formula count blank and choose the column order underscore date. This results is also 0, which means every order has a valid order date. Now let's check for negative profit values. For this, use COUNTIF and choose the column profit, which is less than 0. The result shows 12,544 records with negative profit. This indicates that significant number of orders were sold at loss, likely due to high discounts or costs. This is not an error, but it is an important insight for analysis. Finally, let's check for null quantity values. So use count blank and choose the column quantity. The results here is also 0, meaning all records have valid quantity values. Let's summarize what we found from our data quality checks. Null sales is 0, null order dates is also 0. The negative profit records is 12,544 and the null quantities is also 0. Overall, this dataset is highly complete with no missing values, no critical fields. The presence of negative profit values is expected and will be analyzed further when we study discounts and profitability. With data consistency checks complete, we are now ready to move forward with deeper analysis. Now that we have completed our data quality checks, let's move on to cleaning the dataset. These steps ensure the data is consistent, well formatted, and ready for analysis. First, review all columns in the table. If any column is not clearly understood or not required for analysis, remove it. This keeps the dataset clean and focused on relevant business information. Next, make sure all date and numeric columns are correctly formatted. Incorrect formatting can lead to errors in calculations and visuals later on. Let's now focus on the ordered.date column. This column currently contains both date and time values. Select the order.date column. Go to More Number Formats and choose an existing date format to ensure Excel correctly recognizes the column as date field. At this stage, the order date column is stored as date and time value. For many analysis, we only need the date, not the time. To do this safely, we will create a new column rather than modifying the original one. Create a new column called order_date. In the first cell of the new column, type equal to int, that's integer, of the order.date. Excel stores date and time together as numeric value. With these cleaning actions completed, unclear columns are removed, date and numeric formats are standardized. This prepares the dataset for accurate reporting and visualization. Now that our data is clean and consistent, we'll create a few business-friendly columns. These columns make analysis easier and help us answer key business questions around seasonality, trends, and profitability. First, let's create the core month column because this column is used for seasonality analysis and monthly trends. It's especially useful for business dashboards. Insert a new column and name it month. In the first data row, enter the following formula, that's equal to a text function, and select the order.date and give the format function MMN. So this converts the order date into a short month name such as Jan, Feb or March. This format is ideal for business reporting and dashboards. Next, we'll create a numeric version of the month. Why? Because this is useful for correct month sorting in charts and Power BI visuals. Insert another column and name it order_month_number. In the first row, type equal to month function and choose the order.date column. This returns values from 1 to 12 representing January through December. Now let's create the order_year column. Why? This is used for yearly trends, year-over-year analysis and Power BI slices. Insert a new column and name it order_year. In the first data row, enter year function and choose the order.date column. You should now see values like 2011, 2012. Finally, let's calculate profit_margin. Why? Profit margin helps compare profitability across products, markets, and customers, regardless of sales size. Insert a new column and name it profit_margin. Use the following formula. Use if sales column, which is 0, and profit divided by sales. This formula safely handles cases where sales are 0 and avoids division errors. Now format the profit underscore margin column. Set the format to percentage. Display 2 decimal places. At this point, we have successfully created all required business columns. We now have order underscore month for seasonality analysis, order underscore month underscore number for proper month sorting, order underscore year for yearly and year over year analysis. Here the discount column is in general format, so we'll change this into the percentage and change the decimal places to 0. Profit underscore margin is for profitability comparison. These enhancements makes the dataset analysis ready and perfect for use in Power BI. After creating our business columns, the next step is to perform quick validation checks. These checks help us confirm that the newly created columns behave as expected and that there are no logical errors in the data. Let's start with some basic validations. Order underscore year has no blank values. Order underscore month correctly matches the order date. Order underscore month underscore number correctly matches the month number. Profit underscore margin values are reasonable and not unusually large. All these checks look good. During our earlier data quality checks, we identified 12,544 records with a negative profit. However, when filtering the profit column directly, negative values were not immediately visible. This confusion was caused by formatting and visibility issues. To make this clearer, we'll create a flag columns. Flag columns help clearly label records and make analysis much easier. In the first row, enter the following formula. That is, if sales is less than 0, then negative sales. If not, return and say it is valid. This identifies written transactions where sales values are negative. In the first row, enter if profit is less than 0, then it is loss. Otherwise, it is profit. This clearly separates loss-making transactions from profitable ones. Now, let's analyze loss-making transactions. Filter the dataset where profit underscore status equal to loss. Once filtered, analyze the following fields: the product name and the subcategory, market, a discount, and the shipping cost. This helps answer an important business question: which products and categories generate losses? Initial checks were confusing due to formatting issues. However, after adding the profit underscore status flag, we confirmed that these are genuine negative profit transactions. These records were retained as they represent real losses caused by high discounts and operational costs. It's important to clarify what truly represents a loss. Negative profit is the correct and only indicator of loss. This means the product was sold, but discounts were too high, shipping costs were too expensive, or the cost of goods exceeded the revenue. This is exactly the type of insight businesses care about. Next, let's validate the order underscore shipping dates. Why an item cannot ship before it is ordered? Create a new helper column and enter if ship date is less than the order date, then date error. Otherwise, it's okay. Now filter for date error. There are no records where the ship date occurs before the order date. This confirms our date logic is valid. Next, let's check for duplicate records. Why duplicate distributor files can cause double counting? Apply conditional formatting, highlight and duplicate the values. Repeat the same check for product column. Here's what we found. Duplicate order underscore ID values do exist, but each duplicate has different product IDs. This indicates that multi-line orders, not duplicated data. So no records were removed. Duplicate order IDs were reviewed and confirmed to represent the multi-product orders rather than the duplicated records. Finally, let's analyze extreme discounts. Filter the discount column. So apply a filter discount which is greater than 0.7. All transactions with discounts greater than 70% have a loss status. This clearly shows that high discounting is direct driver of the negative profit. With these validation checks complete, business columns are confirmed accurate. Loss-making transactions are clearly identified. The dataset is now fully validated, trustworthy, and ready for Power BI analysis.